Hello, welcome to this video on volume. This is a Calc 2 subject where we take a region in the XY plane and revolve it around some horizontal or vertical line, generating a 3D volume. In particular, this question is looking for us to take the region between the parabola, y equals x squared minus 1, and the line, y equals x plus 1. That region between those two curves gets revolved around the line y equals 4. The very first step in these problems is always to graph the region. And so we have a parabola that's shifted down 1 unit. We have a line that intersects the y-axis at 1 with a slope of 1. We don't know where they intersect at. We'll handle that later. And now we have this region who needs to be revolved around the horizontal line y equals 4. There's 3 main methods to handling volume of revolution: disk, washer, or shell. With this one, there's a discernible gap between our region and our axis, and so it wouldn't be disk. We have a choice between washer and shell. When you do washer, the rectangle that generates a typical volume element is perpendicular to the axis of rotation. And so that's what a typical washer rectangle generator would do. You rotate that and you have a donut region, a disk region. And so here's the actual 3D volume generated. I'll put a link to this in the description. This is a GeoGebra worksheet that somebody made up, not me, but it's very nice. You can put the curves in and put the parameters in. It'll rotate for you. It's great. And so with that, then we can go with the washer method. Okay. In the washer method, there's 2 radii. There's a radius who gets you to the inside part of it, and there's a radius who gets you to the outside. So what you do to find the inside radius is you draw a line that goes from the axis just up to the region. It's going to move. That rectangle is going to move from left to right. This is just a typical rectangle, and so that's the typical radius there who will deem the inner radius. When you have the axis removed away from the x or y axis, then the radius becomes some kind of addition or subtraction based on how far you are away from the x or the y axis. To get this distance, we'll recognize that there are 3 distances at play. There's a distance that we're looking at, the inner radius. There's how far you are removed away from the x-axis, 4. And then the difference there would be the distance up to the line. And that's the line x plus 1. So then what is the inner radius going to be? That's your unknown. Well, you start with your 4 and you subtract off your x plus 1. That'll give you your inner radius, who will simplify to be 3 minus x. All right, great. How about the outer radius? That goes down through the end of your region. It's removed away from the x-axis. Let's look at the 3 distances that are in play. There's the distance that you are away from the x-axis. And the difference there between these two is the distance up to the parabola. The parabola is x squared minus 1. So how are you going to find the outer radius? You take the 4 and you subtract the x squared minus 1. Simplifying to give you 5 minus x squared. All right, this is the hardest part right here. Picking the right method and then finding the radii involved with that method. Now that you have it, it's all downhill from here. We need to set up the formula for volume by washer, which involves these 2 radii. It's like pi r squared minus pi r squared. There's an inner disk and an outer disk. Washer is just disk in disguise. It's an inner disk minus an outer disk. Outer disk minus an inner disk. And that's how you get the volume. So the last hurdle we have to jump over is, what about the bounds? Where does this move from? What's the lowest x and what's the highest x? We need to solve for the bounds. The bounds happen to be, in this particular problem, where the curves intersect each other. So let's set them equal to each other. X squared minus 1 equals x plus 1. Well, just a little bit of algebra. Let's set it equal to 0. It's a quadratic. But thankfully, it's a quadratic that you can factor. Factors nicely as x minus 1 and x plus 2. I'm sorry, x minus 2 and x plus 1. Right? And then you set these two separately equal to 0 to get the final values there, that the left value is x equals -1 and the right value is x equals 2. Those are your bounds. You're done. You just got to remember the formula, plug what you have right here into the formula, and that's it. We're not going to actually go ahead and integrate. This question is to set up, but don't solve. The integration gets a little nasty, but it's, it's not as bad as it seems. What we have to do is, don't forget pi though. It's pi r squared minus pi r squared essentially as you integrate from left to right. And so the outer radius and the inner radius get thrown into this formula. The bounds A and B get thrown into this formula, and you're done. You did it. You set up the integral that will give you the volume of that particular region revolved around that particular axis. Great job. Thank you for watching. My name is Nakia Rimmer. I'm at CalcCoach.com. I just reached my 4,000th subscriber. Thank you so much. I really appreciate you taking time to sit down and learn some mathematics with me. Please like and subscribe, comment down below, and I'll see you in the next video.